Hey guys, it's Miss Johnson here, and I'm here to bring you your notes on solving quadratics using factoring. That's what we're doing today. We're going to be solving quadratics using factoring. So far, we've only solved quadratics using graphing, so let's just do a little review of what that looked like. When we would graph a quadratic, we'd look at the equation, we'd look for the points, the y-intercept. Y-intercept is pretty easy to find. It's 0, -3 here. Then we would look for the vertex. We would need x equals the opposite of b. That's positive 2 over 2 times a. That's 2 over 2, which is 1. And then we would plug that back in to get the y-coordinate. That's 1 squared minus 2 times 1 minus 3. That's 1 minus 2 minus 3, which gives me -4. So my vertex there would be 1 and -4, which means the axis of symmetry is 1. So I know I have an axis of symmetry that comes down like this. I know that the vertex is 1, -4, which is right there. And I know that the y-intercept is -3, and all that y-intercept does for me is gives me a point to reflect, and I can get my solutions that way, or get my graph that way, I should say. So I'd have a graph that looks like this, and then I'd look for the zeros, and the zeros were where that graph crossed the x-axis. So I'm on the x-axis, I want to look for where it crosses. It looks like it crosses at about the 3 and the -1. And we could go ahead and plug that into our graphing calculator as well to decide if that is where those zeros are. And that would be a way to solve by graphing. Now today we're going to solve by factoring instead. We're going to solve quadratic equations using factoring. So that involves something that's called the zero product property. We would use the zero product property, which says that if you have a real numbers a and b, and a times b equals 0, then either a is 0 or b is 0 or both. So what that's saying is that a and b are factors of that number that give you 0. So you've got to have them, at least one of them, to be equal to 0. So if we're solving using that zero product property, this is what we're looking at here. We want to set the equation that we have equal to 0, and then we're going to factor the equation. Then we're going to set each factor equal to 0, and we're going to solve. Here's a little example of that. We've got this equation, or these two equations, I should say, x plus 5 and x minus 7 equals 0. These are two different factors, okay? This is a factor, and that's a factor. So what they're saying is that either x plus 5 equals 0, or x minus 7 equals 0. So when we solve those, we have x is equal to -5, and over here, x is equal to 7. But we have to get to the factored form first, okay? So that's what we're going to be doing today. We're going to be getting into factored form, and then we're also going to be factoring and solving. So let's take a look at number 1. In number 1, we have x squared equals 6x. So I need to first set set the whole thing equal to 0. That means I need to move this 6x over. So I have x squared minus 6x equals 0. Now, if I'm going to factor this, I don't have a trinomial here. I only have a binomial. So all I can do is take out a GCF. So factor this using the GCF because that's all you can take out. I can take out an x from both sides, or from both parts, leaving me with x minus 6. So I have x times x minus 6 equals 0. And what that means is that either this factor equals 0 or that factor equals 0. So that's the first one, and that one's an easy one because it's already solved for us. The other one would be x minus 6 equals 0. I'd add 6 to both sides, and I'd get x equals 6. So those are like your two solutions. Your two solutions are x equals 0 or 6. Okay. If I look at number 2, now I'm going to move the 5x and the 14 over. So subtract 5x, subtract 14. That would give me x squared minus 5x minus 14 now equals 0. Now I'm ready to factor it. Remember yesterday, over the last 2 days, we've talked about how to factor these things. We want a product of -14 and a sum of -5. That means I need -7 and +2. So my factored form would be x minus 7 and x plus 2. I don't need to split the middle here because my leading coefficient is 1, so that helps. And then that gives me these two separate equations. I have x minus 7 equals 0 and x plus 2 equals 0. So add the 7, x equals 7, and subtract the 2, x equals -2. You can leave them as two separate solutions like that, or you can list them together. -2 and 7 are your two solutions. Let's do another one. So again, I first need to set the equation equal to 0, then I'm going to factor, then I set each factor to 0 and solve. So I'm looking at this one. I have x squared minus 16x plus 64. So if I think of what gives me a product of 64 and a sum of -16, that's going to give me -8 and -8. So I have x minus 8 times x minus 8 equals 0. Now, when we split this into two separate things, we have x minus 8 equals 0 and x minus 8 equals 0. Well, we end up getting the same answer for both here. If I add 8, I get x equals 8, and I get x equals 8. So since I have the same answer for both options, I really only have one answer here. You don't need to list the same number twice. This is a parabola that has only one solution. Let's do one more together here today. I'm going to have 3x squared. I need to subtract the 9x over. So minus 9x is equal to 0. And I'm back to something that has only two terms, so I'm back to needing to factor using the GCF. So since there's only two terms, I'm going to take out the GCF, which in this case would be 3x. That leaves me with x minus 3. So I have that factor and that factor. So I have 3x equals 0 and x minus 3 equals 0. When I divide by 3 here, 0 divided by 3 is still 0. Over here I need to add 3. So I get x equals 3. So those are my two solutions there. And yes, 0 is a possible solution. So I need to list it. I need to treat it as its own solution. Okay. So a few examples on solving by factoring. I'm going to go ahead and stop our video at this point, and we'll finish up the other solving by factoring examples in class tomorrow. Thanks for listening, and have a great night. Don't forget to go back to Schoology and take your quiz.